Dear students, in this session, let us discuss about the Orifice-meter. The Orifice-meter is a device similar to the Venturimeter. So, in the last session, we have discussed about the Venturimeter. So, can you tell me the usage of Venturimeter? What is the usage of Venturimeter? Why it is used? Yeah, you are right. The Venturimeter is used to find the discharge or the flow rate. So, what is the unit of flow rate? Volumetric flow rate or the discharge? What is the unit of discharge? Yeah, very good. It is meter cube per second. So, in case of Orifice-meter also, we are going to determine the discharge only. So, there may be a question in your mind. Then why you want to go for Orifice-meter? Why not Venturimeter? Any guess? Why you want to go for Orifice-meter? Orifice-meter is comparatively a lighter instrument, or we can tell it's a cheaper instrument or a cheaper device economically to determine the discharge compared to the Venturimeter. But what may be the compromise? When it is cheaper, what may be the drawback? It is less accurate than Venturimeter. It is not so accurate as Venturimeter, but it is cheaper than Venturimeter. So that is the pros and cons of Orifice-meter compared to the Venturimeter. So Orifice-meter also works on the same principle of Venturimeter. That is, we are going to apply the Bernoulli's equation at two sections, and we are going to arrive at the formula for the discharge. The discharge is nothing but the volumetric flow rate, namely the meter cube per second. So that is the interest how we are going to proceed with finding the Orifice-meter. We will also discuss why it is cheaper. Can you tell me why it is cheaper than Venturimeter? What is the arrangement of the Venturimeter? We have a convergent portion, then we have a throat and a divergent portion. What about here? There is no convergence. This green is not convergent actually. That's the fluid flow, how it will happen. Now this has only a pipe. Inside this pipe, we have inserted an orifice. This orifice will be looking in the side view. If you are going to see, it will be like this. If you are going to put, yeah. Now can you get the idea? This region and all is blocked. So the flow can emerges only through what? Only through the center portion. Got the logic? So when the fluid is coming, this portion will block the flow, and the fluid can come only through this small opening. This small opening is called as what? Orifice. The small opening is called as what? Orifice. Just as called as hole. So this, since it's passing through the hole or the orifice, the meter is called as what? Orifice-meter. So inserting this device is much easier, or welding this orifice plate is much easier in a tube compared to the Venturimeter. There in Venturimeter, we need to put more amount of machining to make the convergent portion, the throat portion and the divergent. Whereas here it is very easy. Just we are going to insert a disc such that the water or any fluid or whose flow rate has to be measured will be passing only through the center. So this one what you are seeing in the board is not actually the real geometry. It is the path of the liquid which is emerging from this orifice. So we can see the flow is coming. Can you tell me what is the specific location of 2 from the diagram? What is the compared to 2 dash compared to 3 dash? I will put a plane here, 3 dash. So what is the difference between 3 dash and 2 dash? Height. In which area the height is very minimal? 2 dash. Before that also the height is more. After that also the height is very, very high. Only at the location 2 dash the area is minimal. The area is what? Minimal, or the height is minimal. So this is called as vena contacta. When the flow is going to come outside the orifice, it will go like it will try to take a minimal area, and once again it will try to diverge. So we want to identify the location where it has the minimum area is called as vena contacta. That particular section you have to draw a plane. There you have to tap the flow. You have to tap the flow. That is the section 2. Generally, this 2, 2 dash will occur at 0.5 times the diameter of this orifice. Let us say the diameter of the orifice is 5 centimeter. Let us say the diameter of the orifice is 5 centimeter. So where I have to place this plane means I have to place this plane at a distance of 2.5 centimeter. Got the logic, Tony? So it should be placed at a distance of 0.5 times, which is nothing but what? It should be at 2.5 times the 2.5 centimeter from this orifice plate. Similarly, where I have to keep the plane 1. Any idea? Definitely it is little far away from the orifice plate. So this distance is generally 1.5 times 1.5 to 2 times of the diameter. So now let us see this diameter is diameter of the pipe is not this diameter, this is the diameter of this pipe. So if this diameter say some 20 centimeter, for example, then I have to keep it as what? 30 centimeter. I have to keep it as this is what? 30 centimeter. So this distance is calculated on the basis of diameter of the pipe. And this distance is made possible with the diameter of this orifice. Now the diameter should be what? 0.5 times the diameter of this orifice. Then I can locate the point 2 dash and 1 dash. So now you know where you have to fix the location of the first plane 1 dash and the second plane 2 dash. 2 dash should exactly occur at the vena contracta. Exactly occur at the vena contracta where the area is minimal. That is generally obtained at 0.5 times the diameter of the orifice. The second thing is the 1 dash can be located anywhere because the pressure drop length is much more. But even the general thumb rule is it is 1.5 times to 2 times the diameter of the pipe. Any doubts so far? Any doubts? Okay, no doubt. Very good. Now we see, we will try to apply this concept to the Bernoulli's equation between the points 1 and 2. Between the points 1 and 2 and we will try to arrive at the formula for the flow rate, namely the Q. The flow rate is given by what? Q equal to area into velocity. Yesterday also we have seen. Because the unit of area is what? Meter squared. The unit of velocity is meter per second. So when I am going to multiply, I will get the volumetric flow rate. So this is the idea we are going to do it. So here as usual, this pressure, whether the pressure at 1 dash will be higher than 2 dash or what? Where the pressure will be? Yeah, very good. So the pressure at 1 dash will be higher than the pressure at 2 dash. So this water will push the heavier fluid. Here the heavier fluid is what? Mercury. What is the specific gravity of mercury? Is 13.6, which means it is 13.6 times more denser than water. It is 13.6 times more denser than water. We can keep any other fluid also, but you have to generally keep a heavier liquid when you are going for a normal U-tube manometer. That we already discussed in the manometer session. Please go through it. So now this fluid will push the mercury downwards and this pressure exerted by this end will be lesser, so the mercury goes up. The difference of height in the mercury level from the daytime is called as H. It's called as what? H. So with this concept, let us try to go for the derivation of this flow rate. So I hope there is no doubt in the diagram. I am going to erase it. Any doubt so far? Okay, no, there is no doubt. So we are going to try to apply the Bernoulli's equation between point 1 dash and 2 dash, and we are going to arrive at the equation. Let us continue the derivation of this flow rate for the Orifice-meter by applying the Bernoulli's equation between the section 1 dash and 2 dash. The 1 dash is the upstream of the orifice plate and 2 dash is the downstream exactly at the vena contracta where the area is minimal. Okay. What are the Bernoulli's principle? P1 by rho g plus V1 squared by 2g plus Z1 is equal to, what can you tell me the right hand side? P2 by rho g, very good, plus V2 squared by 2g plus Z2. What do you obtain from this equation? What does this equation says? Not pressure is equal. Pressure is definitely lesser. You told that P2 is less than P1. Then how is the pressure is equal? Very good. The total energy at section 1 will be equal to the total energy at section 2. The total energy is contributed by kinetic energy, potential energy and pressure energy. The summation of the potential energy and kinetic energy plus pressure energy or flow energy will be the same at any 2 sections of the flow. That is what is given by the Bernoulli's equation. This equation is called as what? Bernoulli's equation. Okay, fine. Now based on this equation, let us now try to figure it like this. P1 by rho g plus Z1 minus P2 by rho g plus Z2. I hope you are able to understand. I am taking this term negative, this also negative. I am taking common negative sign between these 2 terms. So I hope you can able to understand. This is simple mathematics. Will be equal to what? V2 squared by 2g minus V1 squared by 2g. In the last section when you are deriving the Venturimeter, we assume Z1 equal to Z2. Here also we can assume Z1 equal to Z2. But even then if there is Z1 is also there, we can add. Because both the unit of P1 by rho g and Z1 are same. Because this is also head, this is also head, this is also head. So all the units are same. So I can add up, I can add them also. Nothing wrong in that. So we can see this term and this term. So this term will be equal to what? This term will give rise to what? My H in the manometer. This difference will is only showing me what? The difference of head in my manometer. Got the logic? I have shown the H. So this value will be equal to the H because that is created because of the pressure changes. If there is a datum change also, we can include that. That is H. Okay, H equal to V2 squared minus V1 squared by 2G. What I did, I taken 2G as the LCM. So H will be equal to V2 squared minus V1 squared by 2G. Any doubt here? Okay, fine. We'll move further. Here it is only simple mathematics. Whenever there is physics, I will explain you. Otherwise, just you can follow me. It is more simpler. So it is from this I want to try to find V2 squared. So V2 squared will be equal to what? Can you tell me? V2 squared will be equal to 2GH plus. Very good. So I can take this. After that, I can take this V1 squared. That's fine. Okay. Now, what is the formula? What is the flow rate? What is the formula for the flow rate? Q equal to? Very good. Area into velocity. Very good. Very good. So Q1 will be equal to what? A1 V1. Q2 will be Q1 will be equal to Q2. Very good. Q2 will be equal to? On what formula you are telling A1 V1 will be equal to A2 V2? Or Q1 equal to Q2? What is the physics which says Q1 will be equal to Q2? Yeah, why the flow rate remains same? Here, consideration of mass principle. Consideration of what? Mass principle. So what is mass? What is density? What is density? Mass by volume. What is mass? Density into volume. What is volume? No. Separately. What is volume? Simply. What is the formula for volume? For any volume? Area into length or area into height or length into breadth into height. So I am taking length into breadth as area and this is nothing but what? Some distance. Some height is what? Some distance. This is mass. This is what? Mass. I want to divide both sides by time. Then what will happen to the mass? No. What is this will become velocity. Distance by time will become what? I am dividing both sides by time because then only I can divide. This is also I am dividing by what? Time. So what is this mass by time? What is the unit of mass? What is the unit now? Kg per second. So it's not called mass. Now it's called as what? Mass flow rate. Anything divided by time is called as rate. Is called as what? Rate. So this is called as mass flow rate now. This is called as what? Mass flow rate. So m dot. What is that? M dot. So what about this one? Rho into area into what is this distance by time? Velocity. So what is this m dot now? M dot is not kg. M dot is now kg per second. M dot is nothing but what? Kg per second. Where m is nothing but what? Simply kg. Now m dot is what? Kg per second. Now the principle of conservation of mass says the mass flow rate at the inlet should be equal to what? The mass flow rate at the outlet. That is nothing but the principle called as what? Conservation of mass. Which means m equal to m dot 1 equal to m dot 2 equal to what? M. So what is this m dot 1? Tell me the formula based on this one. What is m dot 1? Yeah, rho 1 into A1 into B1 is equal to what is m dot 2? Rho 2 into A2 into V2. What is the density of water? 1000 with unit kg per meter cube. Very good. So whether the density of water will vary? No, it doesn't vary. So rho 1 equal to rho 2 equal to rho, which means it will become what? A1 V1 equal to A2 V2. So we are able to obtain A1 V1 equal to A2 V2 from the fundamental principle of conservation of mass, which says that the mass flow rate in any section will be always constant. That mass flow rate, that is m dot 1 will be equal to m dot 2. For an incompressible fluid like water, rho 1 will be equal to rho 2 and hence A1 V1 will be equal to what? A2 V2. So because of this only we are able to apply this rule. The basic funda is what? Conservation of mass. Very good. So based on this, what is the thing what we want now is A1 V1 equal to A2 V2. So I can put as A1 V1 equal to A2 V2. What is here V1 V2 indicates? Velocity or volume? How can be volume? Already area is meter squared. If I am going to put meter cube, then what is the unit will be? So what is the quantity this one? What? Velocity. So V1 and V2 are nothing but the velocity. So then only you get a meter cube per second. So please always try to go with the units. Otherwise, if you don't understand, you put a error ahead. So A1 V1 equal to what? A2 V2. Here also is velocity only. From this, what you want, Tarni? From A1 V1 equal to A2 V2, what you want to find? I want to express V1 in terms of V2 because there are two variables now. One is V1, one V2 and H. H can be obtained from the manometer. So I want to try to convert this V1 also in terms of what? V2. Or you can even convert V2 also in terms of what? V1. There's nothing wrong, but we are going to get out V1 in terms of what? V2. So V1 will be equal to A2 by A1 into what? V2. Got it? So I can replace, now what is V1 squared? A2 by A1, the whole squared into what? V2 squared. Got the logic? I am squaring on both sides. Got it? So try to substitute this V1 squared over here. Try to substitute this V1 squared over here. So what is the expression you will get it? So V2 squared will be equal to 2GH plus A2 by A1 the whole square into V2 squared. Okay. So which term we can take it to the other side? This term you can take it to the other side. And which one you can take is common? In these two terms. V2 squared. Very good. So V2 squared into 1 minus A2 by A1 the whole square equal to what? 2GH. Okay. From this what is V2 squared? V2 squared will be equal to 2GH divided by 1 minus A2 by A1 the whole square. But whether you know A2, what is A2? The area of the vena contractor. Area of the vena contractor. I will recall the diagram. So here this is the orifice plate is there. Isn't it? This is the orifice plate. This diameter is what? D0. And I am going to have a minimal area at some location. This is my location. Let us say it is 2 dash. It is 2. So this area is nothing but what? A2. What is this area corresponding to? Tarni, what is this area then? This is A2 means what is this area? This is not A1. You see, what is the symbol I have given? D0. So what will be the area? Here if I am going to be 1, 1 means the area will be A1. But here I have given as 2, 2, so the area is A2. Now what is the area of this orifice? AO. Very good. It is called what? AO. So we are calling this what? AO. Now AO will be bigger than A2 or smaller than A2? Bigger. Very good. So now I am going to define a parameter called as CC. Can you tell what is, can you assume what is CC? Whether the area is decreasing or increasing? After the point, decreasing. So whether it's contracting or expanding? So it's called as coefficient of contraction. Coefficient of what? Contraction. Very good. So it will be equal to what? A2 by A0. A2 will be smaller than what? A0. So this value will be less than or 1 or greater than 1? Very good. Less than 1. Because A2 is less than A0. So definitely CC will be less than 1. From this, what I am trying to tell? I am trying to get A2. What is A2? CC into A0. CC into what? A0. Why I am putting A2 in terms of A0? Because I know the diameter of the orifice. So I can find the area of the orifice. It's nothing but pi by 4 into D0 squared. But I do not know where A2 exists. I do not know where A2 exists. So I can replace, Tarni, you can listen here. We can replace A2 with what? A0 into CC. So what is A2 squared? A2 squared will be equal to CC squared into A0 squared. So let us try to substitute over here. So we can see V2 squared is equal to 2GH divided by 1 minus, what is A2? It is A0 squared, CC squared into A0 squared by A1 squared. Isn't it? Whether I'm clear? Instead of A2, I have given as what? CC squared into A0 squared by A1 squared. From this, V2 squared will be equal to, or V2 will be equal to what is, Tarni, what is V2? From this, I will take the square root on both sides. Square root of 2GH divided by square root of 1 minus CC squared into A0 by A1 whole square. Okay. Now you tell me whether you know CC. Yeah, some mechanism will try to find what is the coefficient of contraction. Whether you know A0, yeah, you know A0. Because what is A0? Pi by 4 into D0 squared. You know the diameter of the pipe also. So you know A1 also, pi by 4 D squared. So we will be in a position to find what? V2 indirectly. We will be trying to find the value of V2 indirectly. Yes, we will continue from here. So now my aim is not to find V2, but my aim is to find either Q2 or Q1. Because we know that Q2 equal to Q1 equal to Q. So since we have found V2, it's enough to find Q2. So what is the formula, Tarni? Q2 will be equal to? No, with respect to A2 V2. It will be equal to what? A2 V2. So I have to multiply this term with what? A2. I have to multiply, this is V2. So I have to multiply with what? A2 to get Q2. So Q2 will be equal to A2 V2, which will be equal to what? A2 into what? This term. Can you got the logic? So I have written Q2 equal to A2 V2, which is nothing but A2 into this V2. I hope it's clear. Now what is A2, Tarni? Once again, whether you know A2? No, we do not know A2. Then how to find replace A2? A1. No, A1 also you can't replace, na? Just now we told a term. What is the term it's called as? We told CC. What is CC? Coefficient of contraction, which is nothing but what? A2 by A0. From this, what is A2? Yeah, A2 equal to CC into A0. Why? Because you know CC, you know what is A0. A0 is nothing but what? Pi by 4 D0 square. So replace A2 also as what? CC into A0. So I am writing here itself due to space and time constraint. So you can see it is CC into A0. Got the logic? So it is A2 V2. A2 is nothing but what? CC into A0 into square root of this value with this value. So any doubt up to here? But generally it's a common practice to represent the, this is not Q2, we can even keep it as what? Q, because Q equal to Q1 equal to Q. So in this one, which are the things you know and which are the things you don't know? G is known. H you can take it from the manometric reading. A0 you can find from pi by 4 D0 square, diameter of the orifice. A1 you can take it from the diameter of the pipe. Okay, so which one you don't know here? CC. CC is generally a constant which will be given in the problem, coefficient of contraction. Sometimes instead of CC, it's a general practice to give the CD value. It's a general practice to give the coefficient of discharge rather than the coefficient of contraction. So you are going to express this CC in terms of CD. We are going to express the CC in terms of what? CD. Okay, just a minute. We are about to complete now. This also fine. This also, if you want, you can put a box for this also. If in the problem they are giving CC, directly you can use this formula and try to solve it. But if the CC is not given, if they are going to give CD, then how to find it? So you see here, CD will be equal to CC into square root of 1 minus A0 by A1 the whole square divided by square root of 1 minus CC squared into A0 by A1 whole square. What is CD? Coefficient of discharge is nothing but a ratio of the theoretical discharge, actual discharge to the theoretical discharge. So this value is given like this. You may be wondering how you have written this formula, where you got from this formula. You see, the CC is also a constant, CD is also a constant. So I am trying to express a new constant in terms of the already existing constants. Why are you doing like that? So to bring in a more standard form. That's the only thing. Otherwise, you can solve with this, even this formula. Sir, how you know this formula? This formula I have written on my own in such a way because this is also a constant. These things are constant. I am going to make a new constant with the help of the previous constants. So I made CD as what? CC into square root of 1 minus A0 by A1 whole square divided by 1 minus CC square into A0 by A1 whole square. Now you can see, Tarnima, can you now tell me what this term can be replaced for? Yeah. It's not only CD, see, this term is here. This both the terms are this one. What will be then this term? CC by square root of 1 minus CC squared by A0 by A1 square is there. It's not only CD then. Very good. CD by square root of 1 minus A0 by A1 the whole square. Very good. So now if I want to get from this equation, CC divided by 1 minus CC squared by into A0 by A1 the whole square will be equal to CD divided by what? 1 minus A0 by A1 the whole square. So instead of this value, I can replace as this value. I can replace as this value. So you can see now Q will be equal to CD into this A0 is still there. A0 into square root of 2GH divided by this value I have to put as 1 minus A0 by A1 the whole square. Okay, that's it. By this, that's it. So I am going to further simplify. One more step, we'll get the final answer. So you can see here. So you can see here. Tarnima, can you take the LCM for the denominator? What is the LCM for the denominator? Very good. It is A1 squared. So A1 squared minus A0 squared by A1 squared. Can you take the square root of both the numerator and denominator separately? So what will happen now? CD into A0 into square root of 2GH divided by square root of A1 squared minus A0 squared by square root of A1 squared will be A1. I hope I don't want to write once again. So the square root of A1 squared is nothing but what? A1. This A1 can be taken to the numerator. So now this left hand side is nothing but Q. So my Q will be equal to CD into A0 into A1 into square root of 2GH divided by square root of A1 squared minus A0 squared. Yesterday, just like yesterday what we told, I am going to replace this capital letters with a small letter because the convention is not appropriate. It's always better to represent the area by small letters rather than the capital letters. So it is Q will be equal to CD into A1 A0 into square root of 2GH. Even if you are writing like this, not wrong, but it's not a general convention to write in capital letters, by square root of A1 squared, small A1 squared minus A0 squared. Okay, so this is the formula to arrive at the what? Whether it's actual discharge or the theoretical discharge? No, it's actual discharge. Why? Even though it's derived, we are feeling that it should be theoretical discharge, but I am telling this actual discharge. Why? Because CD is also there. Because there's a CD that will give the ratio of the actual discharge to the theoretical discharge. Since CD is also there, it becomes what? Your actual discharge. It becomes actual discharge. What are the formula we derived for Venturimeter? Can you recall? It is also CD into A1, A2 into square root of what? 2GH by square root of what? A1 squared minus A2 squared. Where A2 is the area of the throat is there. Where A2 is the area of the throat in case of Venturimeter. This is for what? Venturimeter. Now can you see both the Orifice-meter and the Venturimeter are looking same or not? Yeah. Instead of their throat, here A0 is nothing but the diameter or the area of the orifice. Area of the orifice. In order to bring in such a form, we try to convert the CC in terms of what? CD. So you should know what is the formula for CD. CD will be equal to what? CC into square root of 1 minus A0 by A1 the whole square divided by what is that? 1 minus CC squared into A0 by A1 the whole square. So you should be able to recall or else you go through a derivation and try to find the value of CD. Okay. So what is CD? Coefficient discharge. The third thing, what is the coefficient discharge of Venturimeter? What is the range it is actually? The CD of Venturimeter is what? 0.95 to 0.98. This is the general range. Okay. What do you think the value of CD of Orifice-meter? This is for Orifice-meter. Whether it will be higher than this one or lower? Lesser. Yes, it's not lower. I had to tell properly. It is 0.75 to 0.8 only. Approximately I am telling, I am not telling the exact value. So which means the Orifice-meter is less accurate than Venturimeter. But the advantage of the Orifice-meter is that it will be able to provide a easy method of calculating the flow rate with lesser cost. That is the main advantage of the Orifice-meter. So when you are going to solve some numerals based on Venturimeter and Orifice-meter, we will try to get the actual flow rate, theoretical flow rate, as well as the coefficient of discharge of Venturimeter, coefficient of discharge of the Orifice-meter, etc. I hope you can enjoy this session. In the next session, we will discuss with the pitot tube. Thank you.